Welcome to the empirical rule. Here we have a normal curve, and 100% of the data lies between the curve and the horizontal axis. All of that stuff. The horizontal axis goes out to negative infinity and out to positive infinity. But the empirical rule has some nifty ways to divide this up. If you recall, the empirical rule talks about 68%, 95%, 99.7%. It says, if I draw the normal curve, that symmetric bell-shaped curve, and I notice where the curve changes from concave down to concave up, that spot marks one standard deviation down from the mean. The mean would be in the center. And if I go one standard deviation down and one standard deviation up, pretend that's symmetrical, we have 68% of the data. Just for illustration's sake, let's say our mean is 100 and our standard deviation is 10. Well, that would mean this point on this horizontal axis is 100. When I go down one standard deviation, I'm at 90. Up one standard deviation, I'm at 110. That's pretty typical of an IQ. So we would say 68% of the population has an IQ between 90 and 110. Let's go out another standard deviation. If this is my inflection point that marks one standard deviation down from the mean, I go that distance again, and I'm 2 standard deviations down. If we let this be 100 with a standard deviation of 10, that puts me at 80 on the left side. I go up that distance, that puts me at 120 on the right side, and the empirical rule says 95% of the data lies within 2 standard deviations of the mean. That means we expect, if IQ average is 100 and standard deviation is 10, we expect 95% of the world's population to have IQs between 80 and 120. Let's go out 3 standard deviations. Again, I look for where that inflection point is, and that tells me where I think one standard deviation is, and I go that same distance to go up one standard deviation. Now, I'm going to go down, so I am 3 standard deviations below the mean. I'm going to go up, so I am 3 standard deviations above the mean. If I drawn this perfectly, it would be far more symmetrical, but this is just for illustration's sake. Use your imagination. So between 70 and 130, we think we have 99.7% of the population having IQs within those spots. That leaves 0.3% for these areas below 70 and above 130. Since this is symmetrical, I think half of that 0.3% 0.15% of the population scores IQs below 70, and 0.15% of the population scores IQs above 130. Well, we can define this a little better. Would we all agree that since this is symmetrical and we have 100% under the entire curve, if I cut the curve in half right at the mean, I have 50% to the left of the mean and 50% to the right of the mean. If we're looking at one standard deviation away, when I go down one standard deviation, I'm at 90. Up one standard deviation, I'm at 110. If this was split in the middle like it's supposed to be. This is 68% in the middle, so that must mean 34% between 90 and 100, 34% between 100 and 110. Draw another curve. My mean is 100. I go out 2 standard deviations to 80 and 120. We said we had 95% within 2 standard deviations of the mean. 95 divided by 2, that's 47.5% between 80 and 100, and between 100 and 120. 3 standard deviations out. How much is either side of 100? We have 99.7% within 3 standard deviations of the mean. I cut that in half. We have 49.85% to the left of 100 between 70 and 100 on the IQ scores, and 49.85% of the population have IQ scores between 100 and 130. We can do better. Here's my average mean IQ score of 100. I go down 1 standard deviation to 90, up 1 to 110. We said we had 34% on either side, 68% divided in half. If I go down to 80, well, we said that this whole area was 45%. So if I took that 47.5, bad teacher, take that 47.5%, subtract off the 34%, and now I know this area has 13.5%. And if we went up 2 standard deviations, that slice would have 13.5%. Recall going out 3 standard deviations. We have 99.7% between 70 and 130. We said we had 49.85% between 70 and 100. Subtract off the 47.5 between 80 and 100. That leaves me with 2.35% in this slice. we took this 49.85% and we subtracted off this 45.5%, and we're left with 2.35%. And we've already pointed out that these tails that go out to infinity forever and ever only have 0.15% in each tail. And that allows us to make a lot of computations. If I wanted to find percentage of population with IQ scores between 80 and 110, there are several ways to go about it, but the brute force method would be to add the 80 to 90 chunk plus the 90 to 100 chunk plus the 100 to 110 chunk. We have 81.5%. I hope that helps out with the empirical rule.